So in this video what we're going to go through is the introduction of what inequalities are, what the symbols are, how to read them and ways to remember them. We're also going to go through questions that ask you to express inequalities on a number line and vice versa, and also go through how we can write down the integers that satisfy given inequalities as well. So when we're looking at inequalities, it's important that we know and understand what these symbols mean. So here, when we've got an arrow pointing to the left, that means that's less than. When we've got a little line underneath it, it basically means it's less than or equal to. And when it's facing the right, it's with no line, it means it's more than. And when it's facing to the right and it's got a line underneath it, it means it's more or equal to. Now, it's important you understand what the directions mean as well as what the symbol means. And a way of remembering that is how I always remember it, is that the arrow always points at whichever is smaller. Now, if you remember doing this at primary school, then sometimes your teacher might say that the crocodile always eats the bigger number, and it's entirely up to you which one you prefer as long as you remember it correctly. So for example, if we look at these three examples here, that in our first example, if we look at which one's smaller, well here B is smaller. So how we could say this is that A is larger than B, or B is smaller than A. For this one, the next one, we can see that C is smaller. So again, you could read this as that C is smaller than D, or D is bigger than C. And for our third one, here we can see that 4 is smaller. So again, I could say that A squared is bigger than 4, or 4 is smaller than A squared. And it's entirely up to you which you prefer, how to say each of those statements. But it's always important that you're able to read, because obviously it makes the sort of next stage of inequalities that little bit easier. So moving on to our next one. Now sometimes again you might get asked to represent inequalities on a number line. Now if you are doing that, then as always, notation is always going to be the key thing, and it's always worth making a note of what's in this box here. So when we are drawing our number line and we're representing this with an inequality, that we draw a circle. Now if we don't shade the circle in, it either means it's going to be less than or more than, and if your circle is coloured in, it basically means it can also equal that number. So when dealing with these types of questions, the key thing to remember is that we don't always have to start from 0. So for example, question 1, I'm going to have the number that we've got in the middle, and what I might do is just have a few numbers. Now we don't have to have loads, we don't have to go crazy, maybe 1, maybe 2 like I'm doing here. So here we've got 2, 3, 4, 5. I'm going to put a circle above the 4 because that's what question 1 is telling me to do. And because it hasn't got a line underneath, I'm going to leave it sort of unshaded, and my inequality is pointing to the right, and so that's where my arrow should be facing. So for question 2, again, I start by writing my number 16. I've then got 17 and could write 15 here. Now as you can see here, now I'm just going to make a little adjustment to this particular question and just see what we do if we've got a little line underneath it. So basically this is saying that x is less or equal to 16. So here I'm going to put a circle above 16. Now because it's got a line underneath it, I'm going to colour it in. And the inequality is pointing to the left, and that's the same direction as what my arrow should be facing. So then moving on to question 3, again here we're looking at negative numbers, so I've got -4, so I'm going to have -3 on this side, -5 on that side, and so again I'm going to put a circle around above -4. I'm not going to colour it in because there's no line going underneath it, and the inequality is facing the left, and that's exactly the same direction as my sort of arrow. Moving on to question 4 again. So here again, let me just put a line underneath it, just so we've got a bit of variation in the questions. So again here I'm going to start off with 12, 13 and 11. I'm going to put a circle above 12. As it's got a line underneath it, well it has now, I'm going to colour it in. And I have my arrow facing the same direction as the inequality. Now with question 5, as you can see here, we've got two numbers. So what I need to do is make sure that my line includes those two numbers. So I'm going to start off with 2, then I've got 3, 4, 5 and 6. Now like I said, I don't have to start my numbers between 2 and 6. I could easily have just gone straight from the numbers in the question, but just for presentation wise I'm going for that. So again, I'm going to draw a circle above 3 and I'm going to draw a circle above 5. Now as you can see, the inequality next to it in between the 3 and the x has got a line underneath it. So what I'm going to do is I'm going to colour that in. And the one between x and 5 hasn't got a line in it, so I'm going to leave that unshaded. And then all I then need to do is draw a line between those so it looks a bit like a cartoon dumbbell. And there is my final answer. So moving on to question 6. Again, I'm going to go for -2, -1, 0, 1, 2, 3. I'm going to put a circle above 3, a circle above -2, and then I'm just going to draw a connecting line between those two circles. And again, I don't need to colour any of those in because none of these inequality lines is underlined. It hasn't got a line underneath it, so I don't need to shade it in. So that is my final answer. Now in terms of reading what question 6 means, basically that means that x is a number between -2 and 3, exclusive of those numbers. So I don't want those numbers. So again, in terms of vocabulary, exclusive means not including, and inclusive means including. And it's just something when you're reading out. Now you probably won't face these when dealing with maths questions, but if you ever read out answers to a teacher or to one of your peers, you may want to use this kind of terminology. Now with question 7, as you can see, although it resembles something like question 5 and 6, it's written slightly differently because the inequalities are going in different opposite directions. So again, I draw my number line, and again I'm going to have a few numbers just below and above the numbers that are written in the question. Now when you're dealing with these questions, obviously I've not used a ruler, and obviously the spacing between each of the numbers, although it's kind of similar but obviously not exact, and again that's the whole point of this question. So you just want to try your best. It doesn't need to be a work of art, but it does need to be representative, drawing it accurately. So again I'm going to put a circle around 3. Now because it's got a line underneath it, I'm going to colour it in. Now the difference with this is that the arrow is facing to the left, so I'm going to draw an arrow facing the left. Now for the next one, I'm going to draw a circle above 6. It hasn't got a line underneath it, so I'm going to leave it unshaded, and that one is going towards the right. So there is the final answer for question 7. And moving on to question 8, again very, very similar. So if I have -4, -3, -2, -1, 0, 1, 2. So again, taking this part first, I'm going to have a circle above 3. I'm going to colour it in because it's got lines underneath it, and it's going in that direction. And again at 0, that's also got lines underneath it, so I'm going to colour that in, and this time the arrow is facing the right. And there is your answers for those 8 questions. So then moving on to going in the opposite direction. So let's have a look at what happens when we're given a number line and we need to work out write down the inequality. So again with these questions, so here I'm going to start off by having my mystery number as x. You can call it any other letter. It can be P, it could be A, it could be B. It doesn't really make a difference. Now for this, as you can see, the arrow is facing to the right, so I draw an inequality facing the right, and it's also shaded, so I'm going to have a line underneath it. And as you can see, the number where the circle is at -2, so the answer then is going to be x is more or equal to -2. For question 2, again, I have an x. This time the arrow is facing to the left. It's not shaded, so I don't have to have a line underneath it, and that is at 1. Then for question 3, again, start off with x. The arrow is facing to the right, and it's at -4. And again, I don't need to put a line underneath it because the circle in the diagram is not shaded. And then finally for question 4, again starting with x, the arrow is facing to the left. It is shaded, so I put a line underneath it, and the number in question is at 0. So let's have a look at what happens when we have sort of 2 circles, or double dotted questions is how I usually call them. So here we've got 6 examples. So when your number line looks a bit like a cartoon dumbbell, then what happens is that x is going to be between two numbers. Now for this, x is going to be between 1 and it's going to be at 6. Now at 1 you can see that when your question looks like a dumbbell, so when it looks like this, your answer will always look like this, where both your inequalities are facing the left. When you've got it in two separate directions, then what you'll find is that one answer will be going to the left and one answer will be going to the right. So it's worth just making note of what your answers will look like based on the diagrams that you've been given. So here we've got a dumbbell, so I know that it's going to look like this. Now the next thing I then need to do is look at the circles. Are they shaded or are they not? So in question 1 it is shaded, so that's going to have a line underneath it, whereas at 6 it isn't because it's unshaded. For question 2, again, I set up my answer so it looks like this, and at either end I'm going to put the smallest number on the left and the biggest number on the right, and here neither circle is shaded, so that there is my final answer. For question 3, again, starts off with my answer. Again, I've got -2 as my smallest number, +1 as my biggest number. Both the circles are shaded, so they have a line underneath it. For question 4, again, looks like a dumbbell. So again, start off with these numbers. My smallest number is on the left, my biggest number is on the right. The -1 is shaded, so that needs to have a line underneath it. 3 isn't, so that's unshaded. Now for question 5, you can see here that I've got two separate inequalities, and as you can see, my inequalities are facing the same direction as each of the arrows in the diagram. So tackling with this one first, so this one here. So again, the number is 2, and you can see that the circle is not shaded, so that there is the final answer. For the next part, it's at 5, and that is shaded, so that needs a line underneath it, and so this one has got 2 possible answers. Then for question 6, here we've got x is going to be less or equal to 2, and for the second arrow, x is going to be greater than 1, and again it doesn't need a line underneath it simply because we've got a unshaded circle in that diagram. So another very common question you could get asked at these types of questions is writing down integers that satisfy the inequality. Now sometimes this can lie with the number line, but again we can just mix and match between these questions. So starting off with the first one. Now you don't have to do it this way, but I would strongly recommend that when you're getting your head around this, this is one way of doing it. It's a little bit messy, but certainly always works. So if I start by writing all the numbers between this number and the 9, so I'm going to have 3, 4, 5, 6, 7, 8, 9. Now if it hasn't got a line underneath it, I get rid of it. So I'm going to get, as the 3 and this inequality here hasn't got a line underneath it, I get rid of it. And as you can see in the second one, this hasn't got a line underneath it, so I get rid of it. So my final answer for this question is 4, 5, 6, 7, 8, and there is your final answer. So for question 2, let's just stick a few inequalities in here, and let me just mix it up, and let's just go from there, and let's put one there. So looking at these particular questions, so if I start by writing down all the numbers between -8 and -3, so I've got -8, -7, -6, -5, -4, -3. Now this has got a line underneath, so I keep it. This one hasn't, so I'm going to get rid of it. So I get rid of the -3, so my final answer is -8, -7, -6, -5, -4, and there is your final answer. For question 3, again I write down all the numbers between 23 and 30. Now when you get an understanding of these questions, you'll know straight away what the right answer is without having to rub out any numbers or scribble them out, because you'll just know. So for 23, it hasn't got a line underneath it in this inequality, so I get rid of it. This has got a line underneath it, so I keep it, so that is going to be my final answer. And then finally for question 4, here we've got 5, 6, 7, 8, 9, 10 and 11. Now this inequality has got a line underneath it, so I keep the 5. and this inequality has got a line underneath it, so I keep the 11, so that there is my final answer. Now when you come to questions like question 5, now the key thing you need to remember here is that your x has to be by itself in the middle. So here what I need to do is I need to get rid of this positive 3. Now how I get rid of positive 3 is by taking away 3 from both sides. So I end up with is 3 take away 3 equals 0. X plus 3, well that just becomes x, and 10 take away 3 is 7. So what I now need to do is write down all the integers that satisfy that inequality, which in this case is going to be, if I write down all the numbers, 1, 2, 3, 4, 5, 6, 7, I'm going to lose the 0, so that is my final answer. Now when you move on to question 6, again I need to get x by itself, so what's on the same side as x? 2. What's the 2 doing? Timesing. So I've got to divide both numbers by 2. So from this I get minus 5 divided by 2 is minus 2.5. Now usually I would say leave your answer as fractions, but in this case, because we're dealing with numbers, we want to then just try and work with decimals a lot easier. Now the word integer is really, really important. Now integer is just a more mathematical word for whole numbers. So I need to write down all the whole numbers that are between minus 2.5 and less than 1. So if I write down all the whole numbers, so it's minus 2, minus 1, 0, 1. Now here, minus 2, well minus 2 is less than 2.5 anyway, more than 2.5, so that's fine. But here the 1, I can't include the 1, so I need to get rid of it. So my final answer for this is going to be minus 2, minus 1 and 0. So the main thing to take out from this is that when you need to make sure that before you start reading out the integers of an inequality, x has to be by itself in the middle. If it isn't, you need to get rid of it first before you then start writing and listing the numbers. So hopefully this makes a little bit of sense in terms of the introduction of inequalities, particularly at this level in maths. And like I said, this will nicely move on to solving inequality equations, which will be discussed in our next video.